So I couldn't think of a way to make this lesson interesting, so I just copied Mathceratops 4 times, and he's crawling on the side of the screen. So pretend like that's interesting. So let's talk about cubic functions. Um, the terms of cubic functions, or the parts that make up a cubic function. So this looks pretty crazy. A cubic function has the form f of x equals ax cubed plus bx squared plus cx plus d. I mean, that's like what, 5 letters, and some crazy some powers in there and stuff. But it's not so bad. Um, these are just coefficients. So for example, in this function down here, um, a would be 2, and I've kind of color coded this to make it, pop out more. Um, b is 4, that coefficient there. C is 7. Oops, I already wrote down the 7. C. And then d is 1. So that's just all that means. There's these different coefficients for each of these terms. And this first one is called the cubic coefficient, because it's the coefficient that goes with x cubed. Pretty logical. And in this case, this is also called the leading coefficient because it's the coefficient for the highest power. This is the highest power in this polynomial. I just wrote over it. There we go. The highest power, so that's the leading coefficient. It's the first one. It's leading the charge there. This one is called the quadratic coefficient. It goes with the x squared. Quad just means square. And if we were to just have this here, that would be a quadratic function. Okay. Same thing. This is the linear coefficient. So if we were to just have this, you'd have a linear equation. And this is the constant coefficient. It's just a constant, just a number. Like in this case, 1. So you might hear this called, this is the cubic term, the quadratic term, the linear term, the constant term, something like that. So that's what these different pieces are. And I've given you some examples. Um, here's here's an example where A, B, C, and D are none of them are 0. You might have something like this, where what you'd actually see in the book or in your test or whatever would be f of x equals 3x cubed plus 7x. So there's just 2 terms. And you can think of that as having coefficients of 0. So, you can pretend like that quadratic term is there with that quadratic coefficient, but it's 0. 0 times x squared is 0, so this would just go away. 0 just isn't there. So what this would look like is 3x cubed plus 7x. But you can always think of every cubic function as being in this form. The only thing you can't have is where a is 0, which just means you have to have a cubic term. If you just have 3x squared plus 2, that's not a cubic function anymore. That's a quadratic. So you have to have something x cubed. Maybe it's f of x or y equals x cubed, so the coefficient's 1. Maybe it's y equals negative x cubed, something like that. There's a negative 1, or negative 2x cubed. That's the bare minimum that you have to have a cubic function. And then after that, you can have a quadratic term if you want, linear term if you want, stuff like that. So last example here, to beat a dead horse, we got this. This would actually look like, actually I'm gonna write down. This would actually look like f of x is equal to negative x cubed. And I just explicitly wrote it out, negative 1 x cubed. So you can imagine if someone asks you what's the cubic coefficient, it's actually negative 1. You don't have to write that. If it's, negative 1 times x cubed is negative x cubed, if you want to look at it that way. Plus 4x squared, and then plus 0x, that's just nothing. So, and minus 9, something like that.